Taines here, ready to talk to you a little bit about momentum, more specifically the
law of conservation.
What?
The law of conservation of momentum.
The law of conservation of momentum. So Savannah's out here helping me. Savannah, what do we have down there?
We have a hoverboard.
Sweetheart, I can't hear you.
A hoverboard.
Hoverboard. What else we got?
We got 3 Nerf guns.
3 Nerf guns.
2 tennis balls.
2 tennis balls.
And a bouncy ball.
We also have a bow staff, but it's not with us at the moment. Stop! She's acting like she gets that craziness from her daddy. All right, so we got some demonstrations we're going to show you. We're going to show you elastic collisions and inelastic collisions, and then we're going to challenge you guys to send us some collisions of your own. Seen some different types of collisions, elastic and inelastic, and it's your turn to show me what you have. So I'm going to challenge you guys right now to make a video, 1 of an elastic collision, 2 of an inelastic collision. You don't have to do any math or anything right now. I just want to see both types. Tell me why they're elastic and why they're inelastic, and be creative. I want to see some creative stuff out there. Catch you guys later.
Momentum is a crucial part in learning physics because it describes the very relationship connecting mass, velocity, and direction, and is therefore extremely relevant to real-life situations. That is why it is important to understand the already fundamental law of conservation of momentum. So, what is it? Basically, the law states that the momentum of an object cannot disappear. In more specific terms, not including external forces such as gravity or friction, the total momentum before the collision, let's say the momentum of car A, is equal to the total momentum after a collision with car B. Collisions are classified under 2 types, thanks to the studies of John Wallace and Christopher Wren. Some people say that there are 3 or 4 types of collisions, but for simplicity's sake and for accuracy, let's just stick to the 2 which are most commonly accepted. The first one is called an elastic collision. This type of collision occurs when an object colliding with another causes a transfer of energy to that second object, thus separating and not losing any of its kinetic energy. The second collision type is called inelastic and was discovered by Wallace. And this one is basically just the above example with the 2 cars colliding. Both objects stay stuck together. A way to make it easier to distinguish the 2 types is that objects in an inelastic collision do not bounce off of each other in the way that the 2 balls did in the above example. It is important to note that both examples are perfect, in the sense that gravity and friction are not taken into consideration. Wallace and Wren's aforementioned studies included perfect and non-perfect versions of both elastic and inelastic collisions. For example, if a kid throws a baseball at the window, shards of glass are bound to fly out of the frame, but because the ball is of focus and lodged inside of the crack, it still counts as being inelastic. So, you understand the difference between an elastic and inelastic collision, and now you want to solve one. For elastic, you multiply the mass of the first object with its velocity, adding it to the product of object 2's mass and velocity. Setting it equal to the sum of both objects' masses and multiplying it by the final velocity is the final half to this formula. The first half of the inelastic collisions formula starts off exactly the same. First object's mass times its velocity, plus the second object's mass times velocity. The second half of the equation, however, is the product of both masses and velocities, due to not being separated like the first type, instead being combined in one way or the other. Thank you for watching, and if I had a channel, I'd tell you to subscribe immediately.
Oh, I didn't see you there. Hey, Miss Haynes. So, today I'm here to tell you about the law of conservation of momentum. This law states that in a collision between two objects, the momentum present before the collision will be the same as the momentum after the collision. This is because momentum cannot be created or destroyed in a process. So, basically, momentum between a collision will just be transferred between the two objects that collide. Inelastic collisions. So, let's say I'm on a fast break on a basketball game. I throw an alley-oop to myself off the backboard. This is an inelastic collision because before I catch the ball and I will have two separate momentums. But after I catch the ball and then proceed to dunk it, the ball and my mass will be combined, and then you multiply that by the combined velocity of me and the ball traveling to get the final momentum of that collision. Alright, elastic collisions. So, let's say you're doing your civil duty by washing your hands in order to prevent the spread of the disease. When all of a sudden, a basketball comes flying out of the air and hits your hand sanitizer out of your hand. Did you notice how the two objects flew in opposite direction? That's what makes an elastic collision. And in order to find the momentum of these two objects, it would be the mass and initial velocity of this object plus the mass and initial velocity of this object is equal to the mass and final velocity of this object plus the mass and final velocity of this object.
Hi, I'm Emma. Welcome to my YouTube channel. Today, we're talking about the law of conservation of momentum. Now let's get right on to it. Now, some of you might be wondering, what is law of conservation of momentum? According to the Webster Dictionary, the law of conservation of momentum is a principle of physics that says that some parts in an isolated system remain steady and unchanging over time, even though others are moving. Or in simple terms, total momentum before collision equals total momentum after collision. And in the formula format, P total before equals P total after, and P equals the momentum. There are two kinds of momentum, however, one being elastic and one being inelastic. Elastic is when two objects hit each other and bounce apart, or they hit and separate. Inelastic being two objects that hit and interlock. But Emma, I'm more of a visual one. Never felt real one. Lucky for you, you are required to give me your examples. So let's hop on to those. For my example of elastic momentum, I will be portraying it through these two toolbars. Okay, hold on, I was actually really cool. I want to show you that really quick because that's crazy. But Emma, that was way too fast. I couldn't see the transaction of momentum. You know, you're right. Let's slow that down. Am I gonna need to slow Well guys, there you have it. I hope you could better understand the law of conservation of momentum with my help and its two kinds, elastic and inelastic. Don't forget to like, subscribe, and comment. Thank you and have a great day.
Hey guys, it's Professor Zach here. Today we're going to talk about collisions. One thing you need to know about collisions is the conservation of momentum. Basically says that the momentum of both objects before is the same as it's going to be after they collide. There are two types of collisions, elastic and inelastic. Now, the key difference between the two is how the objects react after they collide. For an elastic collision, the objects don't stick together, and they can carry them off into multiple different directions. This is in contrast to an inelastic collision, where when the objects collide, they're going to stick together, and their masses are going to be combined so we can eventually solve for their velocity. It's pretty crazy. Just think about it. As always, thanks for watching. Professor Zach.